Hi. In this session, we are going to kind of look into the binary search. As told in the previous video, in the linear search video, we will first, rather than going directly into the algorithm, we will first look into some real-time example. Okay, let us take the same classroom example. So there is a classroom. It contains 5 rows of students and teacher is entering into the class. But here there is one difference. All the students in the class are already sitting in some particular order. Let it be descending or ascending. So all the students with starting with the letter A is on the first bench, followed by the students with starting with letter B, C. So they are kind of following some kind of a sorted pattern. So this is one of the condition for binary search. So previously in the linear search algorithm, or we have seen that when teacher want to search for a person called disuser, she was kind of going to each and every individual from left or from right. She was kind of going to each person or each student and checking whether he or she is the person disuser. So here, as they are sitting in some particular pattern, that is, let us take it as an ascending order of ascending alphabetical order. What teacher does over here, rather than going with the first person, she goes with a random person, like a middle or a median, which we can call a median. Like she first goes for a middle, like if there are 5 rows, or like if there are 20 people, or like 20 students in the class, she is going for the 10th student. She checks as they are in a particular ascending order. She check what is his name. If his that student's name, right, let in our example it is disuser. If that student's name starts with the letter C, then it means that D is going to come after that. So basically she can skip the first few students up to kind of C, and then she can do the repeat process with the remaining student, and she kind of follows this repeatedly and until she figures that student called a disuser. So here you have clearly visible that she haven't gone through each and every students in the classroom. Instead, she have skipped a few students initially, and then she kind of again done the same thing. In this way, she is not going through each and every student. The teacher is very smarter over here, but only thing is like the students are in certain ascending, following some sort of a pattern. So given an algorithm, or like given an array in a sorted manner, we can apply the same formula over here. So here we are given an array, say an int array from 0 to 9, and we are supposed to kind of figure out something like 5, or our target is 5. So what we need to do is like first the teacher figured out something called median first. So we need to first figure out the median here. So for figuring out median, let us kind of call L as the zero index of the array, or the leftmost index of the array, and the rightmost index of the array be R. When taking this R, if you are going for the length of the array, please note that you should minus 1 from the length, otherwise you will end up in the array out of bound exception. Then for finding the median, L plus R by 2. So in this case we are having 10. We are so basically here the teacher will land on 5. So basically she already got the value just by kind of figuring out the median. But most of the cases it may not be true. It might be uh, the target element might be smaller than the median or larger than the median. So let's take another example, right? Another target, let it be 3. So in this case, we figured out that the median is 5. So first what we need to check whether median is equal to our target, that is 5, double is equal to 3. If they are not equal to, then what we need to do? We need to repeat this process. So before so here one thing is evident, that our target 3 is not going to be here because the elements over here are going to be greater than 5. So it is definitely going to be somewhere over here. So we need to repeat the process. When I say repeat the process, what we need to do, we need to update this value r, right, to a value median minus 1. So that the new r is going to be 4 in this case. Again we will repeat the process. What is the process? Here we need to again figure out the median, that is L plus R divided by 2. So here our new median is going to be 2. So first we will be checking here whether 3 is equal to 2 or not. No, but we understood one thing. It is going to be the right side, as 2 is less than 3, it is going to be in the right side of 2. So we will be kind of taking these two. We are going to adjust our L. So our L is going to be adjusted to median plus 1. So our new L is going to be here, L plus R. So we are going to go for another median, and finally we will end up in this particular value. So consider a case where the value is not there, then we need to return negative 1. So let us now go to the algorithm. So the algorithm is very simple and straightforward. This is a Java function which consumes the target, array and an index. So here first we are kind of initializing our L and R, that is the length of the array, and like 0, which is the left hand side index of the array. So then we are kind of putting a while loop stating when this loop should only run until L and R, L and R, like till they are kind of equal. If L is either less than or equal to R, that is the like till that time, this loop should only run till that time. Then we are calculating the median value, that is L plus R divided by 2, right? Then what we are trying to do is quite simple here. First, if loop, if our mid element mid element is equal to target element, then return the index mid. Else we are adjusting the, if mid is greater, if mid element in the array is greater, then we are kind of shifting our right. Alright, we are shifting our right to mid minus 1. Else we are kind of shifting our left to mid plus 1. So that is what I have explained in the diagram. If none of these cases occurs, then we are kind of returning back -1. Let us run it and see. So here okay, so here what I have done is, like, I have kept a linear search searching through the same array, and also a binary search searching through the same array, trying to figure out the same target. And I have calculated the amount of time taken by both algorithms. So here it is clearly visible the linear search is taking 19 milliseconds to kind of search for value 5, because it is kind of searching for 1, 2, 3, 4 each element. It is traversing through each elements of the array until 5. Whereas binary search is doing in a smarter way by partition, like by calculating the mid or like median, and kind of equating the target with the median. So here the time you can see clearly visible, it is a 0 milliseconds, because it executed. So in this case it executed only one state, like one particular condition. It calculated a median, and luckily our target is already the median, so it ended up with 0 milliseconds. Thank you. I'll upload this video, I'll upload this code in GitHub and share the link as the description of the video. Thank you.